Hello everyone, so today we are going to do Leetcode daily challenge, intersection of two linked lists. So in this question we would be given with two linked lists and we are required to find out the intersection of both of them. So as per this question, it itself reflects the edge cases that when what would be done that if there are no linked lists, when there are just one linked list, or when either of them don't have something in common or something like that. So it itself reflects its edge cases. Now, before moving ahead, let's go ahead with its uh, constraint. So the number of nodes of list A is m, means both of them are having different number of nodes, and these number of nodes can go till 10 raised to power 4, and node value could go 10 raised to power 5. But here we are not concerned with the node values because we are just we are concerned because according to that only we would be storing the value for checking that if both of them are equal or not or something like that. But I guess we are not guess, but in actual we are not much concerned about the values. We are just concerned about the fact that where that particular linked list is pointing to. So yeah, this particular constraint we are not much concerned. Then this one, that skip A less than n, then skip B less than n. That's according to the list A and list B itself. And this intersect val is 0 if list A and list B do not intersect. So basically the function which we are, not the function, because the function is get this particular only, but I'll see that what it is. I hadn't checked for this particular constraint in actual, so don't know much. But presently, as per our solution, we are not much concerned here for this particular. At intersect val equals to list A skip equal this if list A and B intersect. So somehow if I here only it would be there. Here it is, that intersect val, the value of node where intersection occurs, this is 0 if there is no intersected node. So that's the thing here. Means that intersection value is 0 if both of them don't intersect, and if both of them intersect, then the values which would be there, it would be equal, right? So that's they are saying. And further here, list A, the first linked list, list B, the second linked list, and skip A, the nodes of the number of nodes that are required to be skipped in this list A, starting from the head to get intersected node. And skip B is again for B. So these are the things, and this was all about the explanation of the question. Now comes the part how we are required to solve this question. So see, the first example which I have taken from there only, here it is saying that A1, A1 and A2, B1, B2, B3. So first linked list, second linked list, if both of them intersect, then they are intersecting at this C1, C2, C3. If we are given with something like this, the thing which it was saying intersect equal to 0 thing. So if both of them, like here, both of them, they are not intersecting with each other, right? So here the answer would be 0. We are required to return null basically. And here if either one of them is null, like here it is null, another one is here like going ahead. So there is no intersection, right? So again we are required to return null. So from these examples we can, the inference we get is that if L1 and L2 converge to one common node, then only there would be intersection. That's the thing which question want to say. And at that particular moment, we are required to turn that node which is basically on that which the both of linked lists are converging. Now this is L1 shift to L2 and L2 shift to L1. Basically this what I want to say here is that here if we would be moving ahead in L1, then here L1 shift towards L2, right? Because both of them are intersecting, so there would be a common node which will be like we are directly shifting towards the other linked list. It seems to be like that. And if we would be at this particular point, then it would be something like that we are shifting towards L1. That is converging to a common point where L1 and L2 both converge. That is the thing which I'm saying, and this is the thing which we could use an algorithm. Now this one about the edge case, that if either of them is null, then no intersection is possible. Means this is null, so no intersection would be there. So this is all inferences which we could get from these examples. Now comes the part of coding, that how we are required to code it. So let me show you that how we are required to code it. So here the thing is, so at the first time, this is that particular, that if either of them is null, then we are required to run, means the edge case which is there. And then we will be taking 2 pointers, one for the head A and other one for the head B, so that we could traverse in both of the linked list. That is why we are taking 2 pointers, and because of these 2 pointers only, we would be traversing whole linked list until both of them become equal to each other. So that's the thing here. Basically, when both of them points to same address, until then we would be traversing. So here, if pointer 1 equals to, if it is equals to null, that is the linked list ends up. Basically, right, if linked list ends up here only and it points towards the null, then at that particular point, what we would be doing, we will simply point towards head B. That is, yeah, we found intersection. Else, if that is not the case, then we'll move ahead. That is, linked list is over as it points null. That is its last node, and as there is no intersection for sure, that is, they are not separately given, so it will be point towards list B. So that's the thing here. The thing is, when it points null, right, so we will directly move it towards head B. That's the thing which we would be doing here. And when we get this particular point, and then next this one would be there, then we will see that if it is null or not. If it is not null, then we will be pointing towards head A, right? The same logic which we use in our list one, else we would be moving ahead. So while doing this, if we reach a point that both of them are equal, because it is now already pointing towards head B, right? And here head B would be moving ahead, and if at a particular point both of them point towards a single address, right? Then we would exit this loop and we'll return the pointer 1. So this is the logic behind there. Somehow, like at the first moment, I was thinking that if it is equals to null, then that simply means that linked list is now at the end, so there is no intersection or something like that. But if we think about the fact that we are using this thing in both of them, right? Then the thing is that if it is pointing towards a null, and then we assign it to head B, right? And then at any particular point, because when we assign to head B, then we would be directly going in that particular linked list, and we would be checking that if any point both of them becomes equal, then only we can say that yeah, both of them are now pointing to similar address, and we will be returning that. So this is all for this particular question. And regarding the time complexity, so the time complexity here is basically order of n plus m, because we never know that how long we are required to go. That's why. And the space complexity is basically order 1, because we are just traversing the linked list and not using any extra space here. So this was all for this question. If you have any doubt, you could comment that down. And so this was all. Thank you.